Trends in ionic size. Ionic size decreases across a period but increases significantly from cation to anion. This one is different from trends in atomic size. Atomic size decreases all the way from left to right, but in ionic size it decreases across a period from left to right but increases again significantly from cation to anion. This is cation, and then to anion it increases significantly. Na plus to Si4 plus. All of them have 10 electrons, so they are called isoelectronic because all these ions have the same electronic configuration. They are isoelectronic. So this one across a period from Na to Si across a period from left to right. Moving from Na plus to Si4 plus, the number of proton increases. Effective nuclear charge increases. So we know they are isoelectronic. They have the same number of electrons, but the number of proton increases. When the number of proton increases, the nucleus electron attraction becomes stronger because they attract the same number of electron. But the proton number increases, but they attract the same number of electron. So the size of ion decreases from left to right, from Na plus to Si4 plus. If you look at here, from Si to Si4 plus to P3 minus, we can look at great jump in size from Si4 plus to P3 minus. Si4 plus contains 10 electrons. P3 minus has 18 electrons. Electrons are added to 3p orbital to form P3 minus. So the principal quantum number increases. If you look at the electronic configuration of Si4 plus and P3 minus, the Si4 plus up till 2p6, but P3 minus until 3p6. If you look at the n of P is higher than the n of Si. So that's why that is great jump in size. The completely filled inner orbital electrons have effectively shielded the outer electron in P3 minus. Because you have more inner electron. You have 10 inner electron for P3 minus, but for Si4 plus you only have 2 inner electrons. So the completely filled inner orbital electrons have completely or effectively shielded the outer electrons in P3 minus from attraction of the nucleus. Attraction. Electron-electron repulsion increases because it has more electrons here, and then the electrons are effectively shielded by the outer electrons, so nucleus electrons attraction weaker, size increases sharply, mainly due to the number of n for P3 minus is bigger than the number of n of Si. That's why it's bigger in ionic size. And then when you look at from P3 minus to Cl minus, they all have the same number of electron, but they have different number of proton. From left to right, from P3 minus to Cl minus, the number of proton increases. So when the number of proton increases, effective nuclear charge increases, means more and more positive nucleus. So it can attract the electron stronger. Electron held more tightly to the nucleus, size of ion decreases.